Hey guys, how's everything going on? Just let me check if everything is working correctly. So are you able to hear me properly? Just let me know on the chat, please. Is the sound quality good and it's not too loud or it's not too shallow? Great, so we have people from Spain, India, Turkey, Guatemala, Mexico, more from Italy, and Berlin. That's awesome. Thank you very much, guys, for joining in. USA, India, amazing, amazing. And we are almost 43 during a Sunday, so that's also a great achievement for us. San Francisco. Oh yeah, Design Theory. If you guys don't know, you should definitely subscribe to his channel. He's doing an amazing work, especially for industrial designers. Hello from Hong Kong. Great. All right, so I think we shall start. Great. So thank you very much, guys, for joining in. We'll try our best that we go through these workflows, explaining each step, especially if you're a beginner with, let's say, with Rhino, with Grasshopper, or with Keyshot. So we will create a really simple workflow where we will start modeling in Rhino. Then we will create some textures inside Grasshopper, and then we will take it to Keyshot for rendering. Before that, let me introduce myself. I'm Aman Agarwal. I'm from India, but I've been living in Spain for the past 7 years. And in the meantime, I studied industrial design like a lot of you guys and started my own studio called Gris Design. If you're interested, you can definitely have a look at some of our projects, some concept projects, some projects that we have licensed, or some other for crowdfunding platforms. Apart from that, I have a design journal where I mostly work with Grasshopper. So here you can definitely check what else can you do with Grasshopper. So it's a really interesting tool that you can use for so many applications and many more, that there are a lot of people who are really great at it. After that, you can also check our website as well as our Instagram at Academy, and you can see some of our tricks and tips to get better at CAD modeling, rendering, or Grasshopper. So in this webinar, we will be going through these 3 phases. Okay, so hopefully you were able to download the zip file, which you can found in academy.xyz/webinar. Okay, and you can download the zip file, which contains all the steps that we are going to follow. So once you download the zip file, you should be ready with this folder, and let's extract it here. Great. Just let me know if all of you were able to download the file. If anyone else was having some problem, you can also try with the Google backup link in case the Squarespace link doesn't work out. Okay, so Mayuk says he has the files. There might be a bit of lag when I'm reading the comments and when I'm talking about it, so just be patient a bit. All right, so I think this shouldn't be, everything's fine. Okay, yeah, great. So this is a really fast-paced webinar, so just we will be keeping this webinar in our YouTube channel, so you can always come back and watch the steps slowly on your own pace. So we are gonna just try to fly through all the steps because we have short time to do a lot of stuff, but you can definitely come back and see it in your own rhythm. Okay, so we will start with Rhino first. And in the perspective view, let's import our webinar files. So we will be importing the step 1 Rhino file. Okay, I think it's that one. And let's open it. There we go. And here you will find a technical drawing of a concept design. And it starts with like a cubical shape. And you can see all the steps that we have followed. So let's create this shape from scratch in Rhino. Okay. Great. So we will start with the box tool. And you can see the box dimensions are 120 millimeters by 120 millimeters. And there are two heights. The first height is 4.6 millimeter and the next one is 11 millimeters. Okay, so I'm just going to select the cube tool and we will click on one corner, and with our keyboard we will input 120 units. You can see it over here. Press enter and we will press again 120 units. And for the height, we have two heights. So the first one is 4.6 millimeters. And there we have our base box. We will repeat the same step for the top box. So we'll select the same tool, go to the top corner, click and press 120, 120, and the height in this case is 11 units. All right, so there we have our top and bottom box. Now we can work on the same file, but in general you would kind of want to create a copy when you're working in Rhino to keep a track of the steps, because Rhino is not a history-based modeling system, and in case you mess up something, you can go a step backwards and retrieve that file. So what I'm saying with this is I'm just going to create a copy of this, Control C, Control V, and just move it, let's say 200 units. Okay. Now, what we need to do is, this is a solid cube. Now we want to make it a hollow cube. Okay. So I'm just going to move this top part by 10 units so that you can get access to the inside faces of the box. If you're having difficulty navigating around the geometry, you have to select the geometry and click on the zoom icon so that it centers and focuses on that geometry. Now, I think you are able to follow along so far. There is no complicated steps yet. To create the hollow structure, we will be using a command called shell that you can find in the boolean operations, solid operations, and the command is located here, shell closed polysurface. Okay, so let's just shell the bottom half with a wall thickness of 1 millimeter. Okay, so we select this face because we want to remove this face, and you can see we have removed that face and created a wall thickness of 1 millimeter. And let's repeat the same step. Solid tools, shell, and in this case our thickness is going to be 2 millimeters for the top casing. There we go. Okay, we are just doing it 2 millimeters just to incorporate the texture on top a lot easier. We will have a lot more depth for the texture. That's why the thickness is twice. Okay, so now you have the shell ready, and you can again create a copy, Control C, Control V, or you can also press Alt and click and drag, okay, to create a copy. Or you can select, press Alt, click, and write 200, so it creates a copy and moves it 200 units. All right, now we want to apply the fillets. So you can find about the top fillet on the corners of the box, which is 2 millimeters in diameter. Okay, so just going to go from the top view to the box, and let's go to solid, fillet edge, and we apply the fillet, and the radius is gonna be 2 units. Sorry, 1 unit. The diameter is 2, so the radius is gonna be 1. So let's just select all of these corners. Select all of these corners, and finally these corners. Okay. Any questions so far? Pretty straightforward operations we are doing. And finally, we need to apply the fillets on the corners of this geometry. So there is a fillet hierarchy, you can call it. So for example, if I apply another fillet, solid fillet edge, and if I apply a fillet of the same radius as the corner that we have applied the fillet to, it is going to give us an error. Okay, so let's say if you are applying a fillet to these edges, okay, you will see that it's creating some problems. Okay, yeah, so I'll be incorporating the keyboard trackpad, like tracking the keys that I press in the next webinar. Apologize for that. But yeah, I'm just using Control C and Alt to kind of create the copies, but you can use just a normal copy paste for that. Okay, going back to the fillet, filleting the geometry, let's go to solid, fillet edge, and instead of selecting one by one the edges, you can actually chain the edges like the selection. And here when you click it, you can find that you can select the entirety of the edge at one go. And I'm going to set the radius to 0.5. Okay, so let's press OK. It's still keeping the previous radius, so I'm just going to repeat. Change the radius, 0.5, chain edges. So here you can see there is no issue. I mean, if you can use any fillet amount that is lower than 1 and it should work. Even 0.9 should work. As you can see, it's just that if you provide the same amount, it creates like a point and it can give you an error. So in this case, it's just 0.5. We want really sharp edge. So we are going to apply that to this part as well as to the union of the two halves. Chain edges, chain edges, and finally the bottom part. Okay, so we have the filleted box. You can see how it looks in the rendered viewport. All right, and now we will be adding these buttons and the IR sensor, as well as the disk entrance bay. So let's go to the front view. And it might be a bit confusing when you're having a lot of geometries on the background. So I recommend you just to move it by, let's say, we already moved it by 10 units. So I'm just going to move it by 40 more units. So in total, we moved it 50 units. Okay, you can check it. Minus 50 will put it back to where it was. So we just move it 50 units in the z-axis. Let's go to the front view, and here we can work it a lot easier on the geometry. Okay, so what are the dimensions for that? So the dimensions for the bay is 97 units and a height of 1.2 units. Okay, so let's go to the front view, and we create a rectangle starting from the center of 97 units and 1.2 units in height. I was saying to use it from the center because if you have the object snap turned on, you can directly draw that rectangle at the center of that geometry. Okay, so just make sure you have the center object snap turned on. Let's go to corner of the box, and you will be able to find the center point. And here we say 97 units by 1.2 units. So we have that curve on the center part of that face. If you don't, then no problem, you can create it anywhere else, and you can just move it using the center snap and putting it again in the center snap. And finally, let's add the button and the IR receiver. So just go to the front view. We have a button over here. So I'm just going to go and create a button on the edge of that bay. I'm not sure what was the dimension. It's 10 millimeters. No, sorry. It's 8.2 millimeters in diameter. Okay. So 8.2 millimeters. And we just move it, I think 5 units. 5.5 units. I mean, this is just a concept, so you can improvise on that exact dimension. And we are going to do something similar for the other end, where we are going to create another rectangle from the center and make it rounded. So we take this as the center point, and in this case, the dimensions are 6 by 2.7 units. 6 by 2.7 units, and then you can use the mouse to make the edges completely rounded. Okay, like that. And we move it back 5.5 units to make it like equally distant. Okay, so we have these curves that we will be using to now perform some boolean operations. So the first step is going to be creating the entrance for this disk. So you can either select this curve, go to surface or solid, extrude planar curve, straight, and you can extrude that geometry like that. Okay, or there is a shortcut. You can also select the curve, and you can drag, instead of dragging with the arrow, you drag it with the circle that you see on the gumball. For those who are not able to see the gumball, you need to turn on the gumball option at the bottom of Rhino interface. How did we make the curved rectangle? So to make the curve rectangle, you have to go to the rectangle tool, rectangle from center, and here you select that it is going to be rounded. Okay, you mark that it is going to be rounded, and now you can start 6 by I don't know, it was 1.7 units or something else, and then you can change the dimension by moving the mouse cursor to the center. Okay, great. So I was talking about extruding this curve. So you can extrude the curve by dragging this circular button, and it will create an extrusion of that profile of the curve. As long as you are completely covering the geometry, it doesn't matter if this surface, if that geometry is an open poly surface or a closed poly surface. Okay, so we can go to solid boolean operations, boolean difference. So we will select from which poly surface we would like to remove material from, this one, and from which poly surface we are going to remove the material with. It's going to be this one. And you can see we have removed that part. In case you don't, you are still seeing this geometry, you can delete it afterwards. It's just that you can delete the input by default. Okay, if you don't have it turned on, you can just delete this geometry. Let's repeat the same process for the button and the IR sensor. So let's go to the top view. We have these geometries. We will go to solid, extrude planar curve, straight. And we're just going to give it a depth of 0.5 units. Okay, so here you will see that we have these two extrusions. So we will again remove material from this box using these two solid geometries. Solid difference from the box using this circle, and you can delete that. Again from the box using this geometry, and delete the part. Okay, I hope until here you are able to follow along. In case you just want to practice it, you can still go to the geometry that is in the background, and you can test these operations by these geometries that we have left on the background. All right, now we need to create the button. So to create the button, you can duplicate the edge. So you can use a command called dup edge to extract a curve from brep edge. Okay, so here we have the curve, and you can give it a bit of offset. Let's say we want to give it an offset of 0.5 units. Maybe that's too much. 0.2 units. Okay, and you can create the solid extrude planar curve and make it a button. So if you remember, it was negative 0.5 units, the extrusion, and there we have the button. Okay, the same we can do on the other side. If you have the curve, then it's fine, but you can extract the curve information by duplicating the edge, dup edge, and we extract these outlines, press OK. Just make sure that these curves are not joined yet. So when you extract these curves, just make sure to join them as a single closed curve. Okay, and now you can perform the offset one more time, and we have this profile. We are going to repeat the same process: solid extrude planar curve, straight, negative 0.5, and there we have the geometry. And finally, we will be applying the fillet. So like before, you can always create a copy before applying the fillets. And in this case, we're going to apply a fillet of 0.2 units. This part and this part. Okay, just make sure to zoom in so that you can see it properly. Don't worry about these artifacts. That is something to do with the graphics settings. Okay, so you might see these faceted polygons. It's how your Rhino is treating the geometry, like to visualize it. You can always modify that going to the render settings, the mesh settings, sorry, to be smooth and slower. Like that. It will take a bit longer, obviously, for your graphics card to process everything, but you get a better result. All right, and finally, we have to create the cables. Okay, so to create the cables, you can start with, oh, I haven't drawn the cable over there, but you can get the profile from here. Okay, so it's basically a cross section. So you start with a straight line for the axis. Okay, sorry, just let me get back to the chat. So Sinella Studio asks, the circle is normal, the square aspect? I'm unable to understand that question, sorry. I found this to be low poly in Keyshot. Below, there will be, like when we are going to import the geometry from Rhino to Keyshot, there is a setting that you can always use to kind of avoid this problem, okay? Great, so let's create the cable profile. You start with a single straight line, and then you just draw the cable profile, like the plug profile. In this case, you can just draw a random profile just for the sake of the exercise, and fillet the corners. 0.2 units, that's too less, maybe 1.5 units. 0.2, 0.5 units. And then you have this profile. Okay. And when you want to convert this profile into a solid geometry, for example, we want to revolve this profile, we're going to use the solid creation tool. And we will use the, let me see, it's revolve here, okay, where you select the curve profile, press OK, and you draw an axis. So the axis is going to be the center line that we have drawn. You don't need to select it from start to end, it just needs the direction. So you can select anything in the line. And now, obviously, if you want a complete circle, you just need to go and click on the full circle option here. Okay, and it creates the revolution of that profile. Great. And at last, for the cable, we are going to use a curve that goes through interpolation of points. Okay, and make sure that you just don't start to draw the curve, because it's going to create some uninteresting results. To create a more realistic result, I recommend you guys to start with the tangent, so that as the cable is coming out of this cable plug, it's kind of straight and then it bends downwards. something like that. And you can select and always modify the control points to get a better result. Okay, so there you have the cable as well. Maybe I want to make it a bit longer. Okay, now to convert this cable into a this curve into a cable, we can pipe the geometry. So we can use a command called pipe. You can find the same command. I think it's here. It's pipe, and it's gonna be 1 by 1 radius, so 2 millimeters. And you can just move this curve. Well, before moving, just rotate it 90 degrees so that it's following downwards. And then just move it using the centroid to this central part, like that. Okay. So we have almost the geometry prepared. And you can obviously locate the part to its respective place. You can find more about the dimension in the technical drawing. And then we have our geometry ready. So I'm just going to move it negative 50 units. And there we go. We have our geometry ready to be exported for Grasshopper. Any questions so far? We will try to do like 30 minutes Rhino, 30 minutes Grasshopper, and 30 minutes Keyshot, hopefully. Maybe I forgot to fillet the edges on this side as well. .2 units. Okay, better. Okay, so I think it's pretty straightforward, and in case you are lagging behind, you can always use the geometry that is on the background. Now, let's jump into Grasshopper. Okay, so Mayuk, you're asking how to change the low poly to high quality. That's just a visualization settings. So you right click in the canvas, you go to grid properties, grid options, or any document properties you can write in the command bar. And you go to the mesh settings, and here you can set it to smooth and slower, and press OK. It should correct it. Can we have history of modeling features? Yes, you can do that by this component called record history inside Rhino. But if you have Grasshopper, I think there is no need to use that history-based modeling in Rhino. Okay, Kunal is asking, are you going to upload the live stream on YouTube? Yes, it is going to be available once we finish this stream, and you can click on the same link and watch it from scratch. Okay, so now we have this geometry, and we would like to apply some kind of texture on the top part. Okay, must have seen on the image references that we shared. So how can we do that? So to apply the texture, we are going to be using the Grasshopper plugin that comes with Rhino 6 and 7. And to turn on the plugin, you can either click this Grasshopper icon, or you can write the Grasshopper command and press enter. So I have opened my Grasshopper before. So if you're doing it for the first time, it will take a while to load all the components. And once you have it, you will have this floating window on top of the Rhino viewport. And this window you can maximize, minimize. Just make sure when you minimize it, it's on the left bottom. You can close it and you can get back by clicking the Grasshopper icon. So what happens is that in the Grasshopper plugin, we will be doing almost, you can replicate every command that you do in Rhino, but in this visual module system using a flowchart, or creating a logic, or creating an algorithm, or creating a parametric like structure, you can call it. And that in that way, you can kind of have a lot more control of your 3D model than just raw Rhino, or even other softwares like SolidWorks or Inventor or CATIA or Blender or Cinema. So that is really handy when you are creating some advanced relations between the models. If you're creating some parametric design, it is really a powerful tool. Okay, so to use Grasshopper, I generally use the 50-50 screen technique, where you put the Grasshopper window on the right hand side and you have the Rhino window on the left hand side to see what is happening inside Grasshopper on the Rhino viewport. Okay, you can also put the layers tab until here so that you are seeing the entirety of the geometry here. Okay, so the basic concept of Grasshopper is you have these tabs where you will have these components. Okay, so for example, let's say we want to create a point. So to create a point, you go to vectors, point, and then you construct a point. Okay, and you will see that at the 0, 0, 0 of Rhino, this component has created a point. Now it might also happen that you are seeing this component in a bit different way. So you can change that setting by going to display, draw full icons, so you can see the name instead of the icons, and draw full names. That is something I recommend when you're starting, so that you can understand what is the input and what is the output of each component. Okay, so I'm going to do one thing, that I have a plugin called bifocals that will write the name of the component as well as show you the icon, so you can have both at the same place. Okay, so as you can see, this Grasshopper components are generally made out of 3 steps. So the first step is the input. So you provide values in this parameter. Then you have the command itself. In this case, it's going to construct a point. And then you have an output. So you get a result from that command. So for example, by default, if you put the cursor, you can see the values are 0, 0, 0 in X, Y, and Z. And you can provide a numerical value for these parameters. So for example, if you want the position of your point to be 15 in X, you can double click and write 15 and press enter. So it is going to create a number slider. Okay, and you can connect this number slider by dragging a cable from the output of the number slider. Okay, and when you connect it to the X input, you are now controlling the X value of the point using this number slider. Okay, and you can change the number slider and you can see the point move in the 3D space. You can do the same for the Y value. So double click. If you want like decimal points, you can also write, let's say 12.50. So your number slider will now have decimal points as well in the Y axis. And then finally, you have a value for the Z axis. Okay, so this is a really simple Grasshopper definition where where you are creating a point and then you're controlling the position of the point based upon these three numerical values. So let's say I'm creating another point, and by default you can see the point is being created in the 0, 0, 0 of Rhino viewport. And what you can do is you can now create a line between these 2 points. So a line is a type of curve. So let's go to the curve tab. Let's go to the primitive curves and create a line. Okay. So as you can see, this component is orange in color, which means there is some parameters that are missing in this component. And you can just connect these 2 values and you get a line. Okay. It's pretty intuitive, and you get a visual representation of what is happening inside Rhino through these modules. Okay, you can hide these points by selecting them, pressing the middle mouse button and hiding it. I mean, it's working, but you cannot see it. Or you can also disable them. Okay, so in case of enabling and disabling, it's turning them off and on. And hiding is basically making them visible or invisible. Okay, so let's create the texture. There will be a couple of steps that when you're a beginner, you might not understand properly, but just try to follow it with me. And then we will see if we can have some time to elaborate more on that steps. Okay, so I will be moving this geometry. Okay, Control C, Control V, to more or less to that spot of Rhino. And finally, just select the Move tool, select any midpoint, and put that midpoint in the center of Rhino. Okay, so when you are moving it and you press 0 and enter, it is going to move it to the 0, 0, 0 of Rhino, like that. Okay, and as we know it's 120, so center is 60. I'm just going to offset it by 60 units. So now it's properly aligned to the X and Y plane of Rhino. Okay, so that is something that is all we are going to do in Rhino. Now let's see how we can create the texture in Grasshopper. So to create the texture, first we need to construct a point. Okay, so you can either look for the components by going to the tab, but as you can see, the more plugins you download, you will end up having so many components that you will just get lost. So what you can technically do is you can double click and write CONS, like as you are starting to write, Grasshopper will tell you different components that kind of has the same name. So construct point, and you have the construct point component. And we have a point in 0, 0, 0 of Rhino. Okay. So what we need to do is we need to create a grid of points that populates the geometry. Okay. Something like that. So there are a lot of ways to do it. For example, we can say the first point is in 0 units in X, the second point is in 1 unit, and when you're trying to connect this to the X input, you will see that it moves to 1 unit, but at the same time it removes my connection from the previous number slider. So does that mean we can only input one value in each input? Well, that's incorrect, because you can use the Shift key and input multiple values. Okay, so when you put multiple values, you will have multiple outputs. So here you can put 2, you can put 3, and so on. Okay, but that is going to take us a lot of time. So what we can do is we can create a range of numbers between 0 and 120 and put a lot of points in between those two values. Okay, let's get back to the chat. Kishore is asking, can I bring any CAD model or any other files in step like to apply the pattern? Yes, of course. when you're going to import the step file, it is going to look something like this. So you can do it without any problem. I guess you can't pin the Grasshopper window inside Rhino, so it's not floating window. I mean, in this case, if you have windows, you can write, like you can take the Grasshopper window and kind of pin it like that. So it always occupies half of the screen. In Mac, I'm not sure how will it work, but maybe there is a trick. You can look online. Should we always need to move models to center point? Well, no. You can work wherever you want, but in that case, you have to also factor in that the coordinates for your points will have to start from that reference point. So the easiest is going to be moving it to the 0, 0, 0 of Rhino, because the default values will help us make it easier. But yes, you can work in any space you want in Rhinoceros with Grasshopper. Okay, so in order to create a range of values, we are going to use a component called range. So you go to sets, sequence, and you create a component called range. Okay, and this component will take two inputs. It will take a domain and it will take a step input. So the domain is basically asking what is the minimum value you want and what is the maximum value you want. So in this case, we want a value from 0 to 120. Okay, and how many steps we want. So if you want, let's say 100 points, we set 100 steps. Okay, so if you're starting at 0, you can just write a value, or we need to construct a domain. So we construct a domain. Okay, and there is a component called panel that can help you visualize what is happening at the output of each of these components. So by default, our domain starts at 0 and ends at 1. So you can say, okay, make the domain start at 0 and end at 120. Okay, so our point will be starting at 0 and the end point will be at 120. And you can also see at the output of the range component, you have a list of numbers that goes from 0 to 120. Okay, and by default the step value is 10, but you can say as many points as you want. So we are going to use this range value for the x parameter, and you can see we have 10 points. And if you want 20 points, you write 20. If you want 30, 40, whatever, you can keep increasing the steps to get more and more points in between those two values. Okay, now we have only set up the values for the x axis. We also want to put the same values for the y-axis. And if you just connect it like that, there is something in Grasshopper called data matching, and this is why it is creating a straight diagonal list of points rather than filling the entire geometry with points. So you can go to sets and create a component called cross-reference, and this cross-reference component can create all the possible combination of x and y. Okay, so you have the entire geometry filled with points. Okay, I mean, it's kind of creating like a matrix of values that corresponds for x and y in all possible values of the steps. Okay, so we have the points. Now, in these points, we are going to create a circle. So let's create a circle. So the circle that we are going to create is this one, which requires a center point. and requires a radius. So let's put a radius of, let's say, 1.25 units. In order to see properly the circles, you can hide the points, and you have these circles. Okay. There is an issue here that you can see that these circles, they are kind of on the edge of the geometry. So what you can also do is you can modify the domain so that it doesn't start at 0, but it starts at, let's say, 2 or 3, and it doesn't end at 120, but it ends at 117. Okay, so that you are not creating points on the extremities of your geometry. Okay, so until there are any questions you have, I'm just going to put everything in the viewport so that you can follow along. The domain is just putting a minimum and a maximum amount, and then you are creating a lot of values in between those domains. And the cross-reference component is creating all possible combination in X and Y so that you can use it like this. You can use it in, you can create it in another way. So if you have just the range in X, as you can see, you can increase the list hierarchy. So that is also known as graph, and use it in the Y coordinate. Okay. So they both are same. It's just that at the output you have to remove this data hierarchy that it is creating by flattening the list. Okay, so I'm just going to leave it how it was before. Okay, so I think more or less you guys are able to follow along so far. Great, so right now we are controlling the circle radius using a single value. Okay, but imagine if we would like to control the radius based upon a distance from a point. So let's create a point in Rhino. Okay, and we are going to import that point inside Grasshopper. So you go to params, geometry, point container, right click, set one point to reference geometry from Rhino inside Grasshopper. And now we can calculate the distance between this point and any of these points, and based upon the distance we are going to control the radius. Okay, so how can we do that? How do you hide the points? First question. So you select the construct point component, you press the middle mouse button, and you hide it using this icon. Okay, so it looks like this grayish cement color. And then Mani is asking, what does flatten mean? So flatten is basically if you have a data tree. So let's say you have a Amazon box, and inside box you have a small box, like let's say 3 small box, and inside those 3 small box you have 3 balls, 2 bats, and 8 stumps. Shout out to the Indian guys. And when you flatten the list, you basically put everything in the same box. So it's 13 items in the same box. There are no smaller boxes. Or talking about in the data tree concept, if you have a tree, you have lots of branches. Okay, and on each branch you might have more branch, and then you have the leaves. Okay, so when you flatten a list, you basically create a single trunk with all the leaves. Okay. Why? Well, both of these list hierarchy have their own advantage and disadvantage in order to have a better control over your data flow. For now, don't worry when you're starting. And in this exercise especially, it's really simple exercise, but just a simple analogy on how to understand what is flattening. Okay, so we have these points and we have the point that we have drawn. Can you use a cross-reference point to create a 2D input, or can do 3D input? So you can get closer to the cross-reference point and you can add one more, and you do that for 3D. So you should create a 3D grid as well. You need to get closer to the component to access these additional inputs. Gracias, Martin. Okay, so we have this point and we have these points in the grid. So how can we know the distance between these points and this point? So a really simple way is to create a line that starts in this point and goes to these points. Okay, and you can see the effect. So if you move it, you see these points, they change their length. Okay, and if you measure the length of these points, you get a list of values. Okay, so the closest point is, the lower the distance is going to be, and the farthest the point is, the longest the distance is going to be. So instead of using a fixed value, I'm just hiding the line because we don't want to see the lines anymore. So instead of a fixed value to control the radius, you can use these length values for the radius. Okay, so when you do that, there is a problem. As you can see, the length values that it is receiving for radius are really high. Okay, so receiving lengths like 91 units, 68 units. So that's too much. So is there a really simple way to reduce the length proportionately? I mean, I would have asked you, but there is a bit of lag. So the easiest way is just to divide the number. So it's a division component. Division, you divide the length with certain value, let's say 20, and see what does it do. So as you can see, it creates a lot better result, and you can keep on dividing until you get to a point where the circles are not colliding with each other. Okay, you can divide it with even higher value. So you can write 200 to divide it with higher value. Okay, and you can again go back to the steps and increase the density of the points by increasing the steps. Okay, I'm just going to switch to the rendered, wireframe viewport. Okay, so here you have these circles that is somewhere at the bottom. Okay, and you want to kind of extrude it. Okay, so we're going to extrude these circles. Okay, before we extrude, just you can test whether your algorithm is working by moving the point, and you will see when you move the point, the texture kind of adapts to the position of the point. Aditya is asking, can we get an exponential or logarithmic changes like division? Yes, you can. You can either use the math components, I think it's polynomials, you can do it from here, or I have shared with you guys a Grasshopper file, which we will see just in a moment, where you can do it in a really interesting way, okay, using a graph mapper, what we call it. So here I'm just gonna put it in, let's say, in a corner, and the rest just adapts more or less. Okay, so we want these circles to be extruded. So to extrude, you create an extrude component, go to surface, freeform, extrude. These are the profiles, and you need to provide a direction. So in this case, the direction is going to be in the Z direction, like that. And you have created extrusions of that geometry. You can cap these extrusions to convert them into a solid geometry, or you can first convert these circles into a surface and then extrude it to create a solid volume. There are components that specifically do it. So you have a component, let's say if you have a circle, I import that circle inside Grasshopper, and there is a component called boundary surface that can convert a planar curve into a surface. The only issue with this component is that it takes too much time. You can achieve the same result by what we call data conversion inside Grasshopper. So when you connect a node with another geometry node, so let's say you connect it to a surface node, Grasshopper understands that you want to convert this curve into a surface. Okay, so I'm just going to create a surface node. All right, connect it to the circle input. It's going to take a while. As you can see, it took me half a second. But now we have the planar surface. And now we can extrude it in the Z direction by some value. Okay, it's taking a bit of time because there are a lot of geometries. Okay, so there we have it. Here you have the geometry, and now in order to get this geometry inside Rhino, because right now this geometry doesn't exist inside Rhino, you need to perform an operation which is called baking. Okay, we need to bake this geometry. So to bake a geometry, you just right click on the output and you click on bake. All right, and there is an option called grouping the geometry, which I highly recommend in this case because you have a lot of extrusions and it will be a chaos if you don't group it together. And you press OK. So it is baking the geometry, and you have that geometry now in Rhino. Okay, so were you able to follow along this far? Now you just go to front view and you locate the texture to whichever position you want. So if you want it, like let's say there, and then you want it to move it half a unit in the negative 0.5, you can do that. And there you have the geometry. Okay, so until here you only have the geometry, like we haven't created the texture itself yet. So how can we create the texture? So once you have the geometry positioned to the place where you want to apply the texture, you can go to the geometry, ungroup it. Okay, now we have set it up, and you can apply the boolean difference operation. We want to remove material from this geometry and make sure you delete the input so that it's not over like it's not keeping those geometries at the spot, because it will be a really hard way of removing it later on. So you just start removing slowly, section by section. I mean, you can technically remove for everything, but it might crash Rhino, so it's better you do it step by step in small batches. Okay, meanwhile, if you guys have any question, thanks Kunal about the explanation regarding the flatten. Okay, so once you follow the Boolean difference operation until the end, you should have a geometry with the perforations on the surface. I have included in a new layer for you guys the render export, where you basically have the same geometry, and almost I have put the geometries in a proper way. Let's see if it doesn't crash. Maybe this is taking too much time because I bumped up the visualization mesh quality. Okay, anyways, you can still see it in the shaded viewport, sorry, wireframe viewport. So I have created a box to put the design upon. You have the top and the bottom part. I have added a couple of legs, and then you have the cable at the back side. So now, before we move ahead with the Keyshot part, let me just explain super fast. Just going to delete these geometries. You can open the Grasshopper file that I have shared with you guys. And if you open it in the, I think it's in this tab 2, you can just drag and drop to open the Grasshopper file. You will see there are a couple of ways that you can use to create this design. So for example, I'm just going to hide the bottom one and start with the top one. So the top one is the simplest, where you have the points, you use a constant radius to control the radius of the circles. In the second case, you start with a point, okay, this point, and based upon the distance from that point, you are controlling the radius, and this is what we have done now. Okay, you can you can do the same thing, but now you can kind of remap the distance so that it's between certain value and certain value, because before you cannot control the minimum and maximum amount, but if you remap these values, you can control it. So let's say if you're going to injection mold and you need a minimum radius to create a better result, so you can tell it, okay, so the minimum radius should be 0.5 units. So the minimum circle radius will be 0.5 units, and you can say the maximum is 2 units. So you get that gradient, okay? So you can control precisely what is the minimum and maximum that you want using the remap component. And finally, there is a bit more advanced way of doing it using the graph mapper. So here, as you can see, you are using a graph to control the distribution or the gradient of the texture. Okay, you have a lot of types of graphs. You have conical, you have Bezier curve, you have sine wave, so you can definitely just move it top and bottom and just get the desired result that you want. So these are some interesting way you can use graph mapper. You can find it here in the params input, and use it in different creative ways. And you can also flip the graph mapper, so you can have the points, bigger points in the center and faded points at the outer side. Okay, so these are certain variations that you can do to create that texture. Okay, so let's get back to this final output. Before exporting this geometry, I highly recommend you guys to group every object in a respective layer. Okay, so what do I mean with that? Just let me see if my graphic card handles the mesh. Okay, it could. You create a layer for, let's say, the main body. So you select this part and this part, and you put it to the main body layer. You create a new tab, a new layer for cables, and you put the geometry related to cables on that layer. Why we are doing it? Because when you're going to import this geometry inside Keyshot, it will be a lot easier to now put materials to these geometries in one step, rather than you finding it individually in the data tree. Okay, so I have also included a step 3 file. If you look, this is a Rhino file, and I have noticed that Keyshot is having problem with the Rhino 7 files. So I recommend you guys that when you're exporting the geometry, you select the geometry that you want to export, go to Files, Export Selection, and then you choose Rhino 6 instead, or Rhino 5, okay? Because Rhino 7 files are sometimes giving some problem. Okay, so now let's move to Keyshot. Any questions so far? How did you achieve the perforation which is fading out in all direction? You had 4 lines. Okay, so in case of perforation fading in all direction, you can also use instead of a point. So in this case, if you have a point, I'm just gonna turn off the extrusion so that doesn't take that much time. Okay, just gonna turn it off. Okay, so if you have a point and you're doing the same thing, you can do the same thing using a curve. Okay, so imagine you have a curve like this, and instead of a point and line, you can import this curve, pull the points to the curve, and use that distance, as a factor. Okay, so here the curve, the farther it is from the curve, the bigger it's gonna be. So instead of using a spline like this, you can also create a let's say a rectangle, and you use that rectangle instead. Okay, so you can scale it and get different results. All right. When I use the Keyshot plugin for Rhino 7, I don't have any problem even with updating the models in Keyshot. Yeah, probably they have resolved it, but in just personal experience. Okay, so let's get back to Keyshot, and we are gonna open the file that is the step 3 file in Keyshot. Okay, so you have to do a couple of steps before we press OK to import. So the most important thing is that you import the NURBS data in the geometry input. Okay, and this will come in handy with, I think someone was pointing out that this happens in Keyshot, that you get these jagged edges. So if you import the NURBS data, you can subdivide the mesh to create a finer, high resolution mesh later on inside Keyshot. Okay, so don't forget to do that, because you cannot undo it once you import it. So let's import the geometry. Okay, somehow maybe you're not seeing anything. Just right click anywhere and click on center and fit model so that everything is center and fit and the viewport. Okay, so I recommend you guys to have a look at one of our posts at academy.xyz/learn, where we explain how you can achieve really good results with really simple steps to create a custom HDRI. You can have a look at it over here, or you can also follow the steps in the Instagram post where we explain the steps one by one. Okay, so we're gonna do it together, don't worry. So the first step is to change the lighting settings. Okay, so let's go to Keyshot. So the first step is going to the lighting settings, and instead of a basic calculation of lights, we want to calculate it using the product parameters. So you have a lot more ray bounces and you have a lot more accurate result of render. After that, we are gonna go to the step 2, which is add a basic gray plastic material to all of the geometry. Okay, so let's go here, go to plastic, and just create a hard rough plastic gray material and apply to all of these layers. Okay, layer 1, layer 2, 3, 4, and 5. Okay, so once we have that, now we need to go to the to create a new HDRI environment. Okay, so let's go to the HDRI environment tab and we create a new environment, a blank environment. Okay, custom environment, and we go to the HDRI editor and turn off the background to almost black color. Okay, now we are gonna create a light source. Okay, so to create the light source, we are going to add a pin. I'm gonna press done over here, and you can see at the model, and you can move this pin light in order to create the desired result. Okay, so I have done some tests. I'll just input the values by default. So I'm gonna create a light that is a bit smaller, maybe 10 units in radius, but with high intensity. That's a 60 units of intensity. And then we're gonna just move it to create like a diagonal shadow in the geometry. So maybe negative 121 and something around 28 units. Okay, so that looks interesting. So let's say we want to render our first scene using this perspective. So you can go to camera and you can add a new camera and call it perspective 1. And you can fine tune it, because I did it just with the mouse, so it might not be accurate. So you can set the azimuth to negative 90 degrees, inclination to 90 degrees so that it's looking from the top side. And one more thing that we need to do is we need to change the focal length, because for products it's generally around 150 and 200 millimeters, so that it doesn't distort so much of the geometry. So you can look at it in this way and you will understand it a bit better. By default it was 50 units, and you can see how distorted the geometry is. And if you change the focal length to 200 units, you get a bit more orthographic view. Okay, so again, sorry, I changed it back to -90, inclination 90 degrees, and just get a bit closer to the geometry. You can center and fit part to kind of put everything in the center, and finally save this camera. Now we just are left with filling out the materials. So for example, we have the cable, okay, this part, where we can apply a metallic material. So let's go to metal, let's go to stainless steel, polished, and we apply it to that layer, okay? And you can get closer to that geometry to fine-tune it. So in order to edit this material, because we are applying a default material, you can double-click the geometry, or you can go to materials, and here you can see the silver polished. Did I apply silver polished? Well, I'm sorry, you can put it as maybe stainless steel. Which one is the stainless steel in the S? Still polished? Yeah, it's there. Still polished. Okay. Now, I'm gonna add a bit of roughness to the metal, so you can increase the roughness, and you can see the higher you put the roughness, you will see this matte finish on the material, metallic part. So I'm just gonna put it to 0.1 units. Okay, and then for the cable, let's double click. We are gonna leave everything else like this and just put it give it a color. So you can decide which color you want, and there we have the color for the cable as well. Something around there. Okay, so there we have the composition. Let's go again and reset the camera, and we have the overall geometry. You can change the box material at the bottom. You can put it to something other color if you want, maybe something a bit more bland, and we can change this material by going here and giving it a bit more brightness. Maybe this is a bit more dark, something like that. And there you have it. Now what we have to do is we just need to render the scene. So to render the scene, we just press the render button. You set up the resolution over here, okay, and you set up where you want to save it, and in the output, in the options, you set how many samples you need for the render to process. So samples are basically how many ray counts Keyshot is performing, and you can know about it by pressing the H keyboard, or you can turn it on in the view heads-up display. So you can see the longer you leave it, the more sample it calculates and the better render result you get. So for example, with 60 samples, I'm getting more or less a good result. So I will just put a bit more, like 80 samples, and then just press render. Okay, so that's gonna be a really typical workflow starting from Rhino, where you model the geometry. You take it to Grasshopper and apply the texture, and then export that geometry to Keyshot. And in Keyshot, you first of all do some basic stuff like change the lighting settings, you correct the focal length of the camera, you apply a clay material to all of the geometries to understand how the light is going to affect the scene, and then you start applying the materials to those geometries. You can always download more materials from the cloud library, or learn to create advanced material by managing the material graph. Okay, so I think that's gonna be it for the exercises. So just let me know if you have any questions. So Bilok is asking, how can you do the same thing when the surface is not straight, be it like a donut or a sphere? That's a good question. So it depends how your surface is. So there is a concept in Rhino or in NURBS workflow, which is called trimmed and untrimmed surface. So if you have a surface, let's say like a donut, this donut is basically a surface. It's not trimmed surface, it's just a single closed surface. If you draw a normal rectangle, that is also a single surface. But if you draw, let's say, a curve, and you convert this into a surface, this is actually a trimmed surface, because you can always untrim the surface back to its original shape. So in NURBS workflow, when you create a surface cannot have more than 4 edges. Okay, it's always going to have 4 edges. In case of a donut, you first have a flat sheet of paper, we'll call it like that. You kind of fold it and you end up with a cylinder. And if you fold it again, but now in a circular way, you end up with a donut. Okay, so you have the seam over here, and then you have the seam over here. So when you have a non-trimmed surface, it's a lot easier to do this kind of operations in Grasshopper. Wait. Okay, so instead of using that geometry as the starting point, you can import this surface inside Grasshopper. Set one surface, and then you go to Surface Tools and apply Surface Frames. And then apply the UNV parameters. Okay, so these are frames. So frames are basically point with orientation, like a plane, and you can draw circles on those frames. Okay, and you can again do the same thing with the radius. You can use a point, you can calculate the distance between the point and the frames, and use this point as an attractor point to control the radius. You need to obviously divide it or multiply it with some value. And you can also create a gradient with that. Xshot is asking, how do I create these colorful wireframe images? Yes, part of it. So for example, if I have this geometry, I go to the wireframe viewport, And in the layers setting, you can change the display color to, let's say, blue. And then you can create a command called view capture to file that can save the viewport without any background. And then you can post-process in Photoshop, applying some hue and saturation filters. How is the inside of the cylinder is pink and yours is black? That is a concept, no, not a concept, that's a setting that you can change inside the shaded viewport, and you add a backface setting and you color it with a single color like magenta. Why? Because in that way you can understand which is the positive side and which is the negative side of the surface. Okay, so just look for how to turn, like how to set up the backface of a surface. Okay, how to know when we have to flatten something? Well, that will require a bit more elaboration. In general, if you're having some issues with the data tree, I mean, it's really relative. Like, I cannot give you an answer to that question just like this. It depends upon case by case basis. In this case, we are flattening it because we don't want any data hierarchy. Because it's really simple operation. We don't even need to flatten. It should work without any problem. But in some cases, if we perform more actions, it might give some issues. All right, so I think that's gonna be it for today. Really appreciate you guys joining in. And before closing, I would like to talk about our online courses if you're interested in what we do. So you can find about all our courses in our webpage. So we have right now courses for Keyshot, Rhinoceros, Grasshopper, and advanced texture surfacing. So you can go to the webpage and you can find about the Rhino course. So it's 12 hours on the weekends. You can find about the dates at the bottom of each course. When is the next session? And you can ask more info by clicking this button and filling out the form. We have Grasshopper course where we go from from scratch, like without knowing anything of Grasshopper, to create really interesting parametric geometries, some textures, mesh and subdue workflow, and other really important data tree manipulation operations, okay, which is really fundamental in managing Grasshopper to its maximum. We also have the advanced parametric texture course where if you're interested you can learn to create cool textures with these parametric workflows. We saw one of it, but you can create really interesting textures in Grasshopper and gives you a lot of flexibility. Apart from that, you can export it to SolidWorks, Fusion, and other CAD softwares that you work with, and make Grasshopper an integrate part of your workflow, because you cannot create these textures in SolidWorks easily. I mean, but you can do that in Grasshopper, and you can understand how it is being made step by step, and you can always improvise on these textures on the go. And lastly, we have the Keyshot course. Again, you go from totally nothing to materials, material graph, HDRI, animation, creating the fuzz material, and other camera tricks and other general tricks of Keyshot. So do let us know if you are interested in our course. Just you can write us on the email info@academy. You can write us on Instagram or LinkedIn, or just fill out those sign-up forms. Okay, so that's gonna be it for today. So Bilok is asking, it's a silly question, but he wants to know how much does one need to know to join the advanced course? Well, if you are comfortable with data tree, like you can check if you're comfortable with these concepts on the Grasshopper live course, then you can join the advanced course. You can join, like, we're not going to stop you. It's just that depending upon if you are able to control these concepts, apart from these, but the basics like data tree, how geometry is being made in Grasshopper in general, data matching, it will be a bit difficult to follow during the course. Okay, can you make other pattern other than circle, like star or organic shape? Yes, you can technically go and just replace the circle to anything else. So you can replace it with polygon. Okay, no, not this polygon, the other polygon. So the plane is going to be the same spots, and we are also going to just change the radius. So you can see we have hexagons, you can make triangles, segments 3, or triangles. Okay, so you can make any shape you want. Okay, you can also draw any shape, like let's say you want to make a shape like this and move that texture to that spot. You can import that curve. I'm just going to draw a point for reference. Point, set one point, and then you move this geometry to those points using vector 2 point. These points and these points, like that. Okay, so you can move that, and then once you move it, you can use the distance to kind of scale the object. The centroid is going to be the same as well, so I'm just going to move the centroid as well to those spots, and then use the scale factor like that. So you can put any shape you want instead of the circle. Paul is asking what is the configuration of my PC. It's just a ThinkPad P50 from 2016, and interestingly, I'm just using half of my CPU for course. I'm sure it's not working the best. It might be looking like that on YouTube. At the same time, I'm streaming as well. So yeah, I highly recommend going for the workstations like Dell Precision or Lenovo ThinkPad if you're going to use laptops. You can also get like a custom PC for whatever workflow you are more focused upon. Okay, can Keyshot use GPU? Yes, it can use GPU, but in my case I have a really weak GPU, so I'm just using the CPU. There is a difference between the results between the GPU renders and CPU renders, so just make sure you're starting, like you're creating the renders from scratch with GPU, so that you can see what is the end result, rather than making everything in CPU and at the end you're switching it to GPU. So it will create some variations. Also, iGGPU doesn't support NURB renders. Probably yes, but if you are importing NURBS geometry, you can always right-click and retessellate. It's gonna take a while. Let me just pause it and retessellate. Yeah, it's taking a while. I'm just gonna do it for a simpler geometry like this. Retessellate. Okay, so here you can always retessellate the geometry to a higher density of mesh counts. Okay, if you are definitely gonna use GPU without rendering the NURBS geometry, you can increase the polygon counts. All right, guys. So do let us know if you have any questions about our work or any suggestions or anything. And you can watch the recorded webinar. We will share you we will share you the link with an email with everything else. Okay, and that's gonna be it. Thank you very much, guys. See you guys in the next webinar. Okay, bye bye.